Hello, everyone. My name is Jimmy Devany, and I'm at Northern Arizona University under Dr. Chun Sing Jun Ho. And we are working on the analysis of payment conditions through sensor vibration data. So our challenge was focused on infrastructure and monitoring payment conditions through vibration data. And so payment conditions and how to measure them have become an important focus for highway agencies. And in the past, payment conditions have been monitored through IRI, which stands for International Roughness Index. And this method can be costly and ineffective because it only gathers it gathers 10 points over the course of a mile. But as you know from driving on any freeway, there's a lot more than 10 cracks in the road over a mile sometimes. And so what we did was we came up with an idea to provide a cheaper method that also provides more in-depth vibration data. And they would be attached to each tire suspension versus being on top of the car, which wouldn't accurately gather all the data that we could. So our main objective was to integrate this vehicle-based sensing system and a full car model through MATLAB to better estimate the asphalt roughness and identify critical cracking locations with better accuracy. So our approach, we looked at two sections of the I-10 in Phoenix, Arizona. The first being a north and southbound freeway, which was from Chandler Boulevard to Baseline Road, and the second being from 27th Avenue to 51st. And so these two pieces were split between me and the other student on the project. He did the north and southbound, and I did the east and westbound data. So we kind of gathered all the points from that. And then as you'll see, as I get farther, we compiled our data and put it together to kind of put it to the ultimate test. So in the two softwares that were used throughout our project were mainly ArcGIS and Excel for me and the students' purposes. We were kind of we gathered all the data for us. So in the bottom left picture, this is ArcGIS right here, and we use that to be able to map all of our points together and be able to select data. So the highlighted green points along this data right here, those are IRI points. And then as you can see, all the darker green mini dots here are going to be our ZG data, which is basically the acceleration data from our sensors. And so what we would do is we'd take one of the IRI data points, we'd take a bunch of acceleration points around it, and then we would go into Excel, drag that data in, match it with the IRI data, take an average, and be able to get a singular value for the ZG data matching to a corresponding singular IRI data. And then what we did was our goal was to gather a bunch of those to be able to say, hey, as our ZG data goes up, does our IRI data go up correspondingly? Because that would indicate that our data was accurate and that we're doing what we need to do. So the next picture next to it is the sensors that were on the car. And there was 5 sensors in total. There was 4 on each tire, there was 1 on each tire. And then there was 1 in the middle of the car. So yeah, that was kind of how we gathered the data and got all those points. And then, so now here's kind of towards more of the results. These graphs here, so this first graph is just my data for east-westbound. And what we did was, so we matched IRI with ZG, and we put them together here, put a trend line in there, put an equation and R squared value most importantly. And our goal was to get something above 0.8 for an R squared value, which is a correlation coefficient, basically saying that they do have a pretty similar tendency. And so that the 0.8 was pretty good for the east-westbound, and it got even better when we compiled our results with the other student. We ended up with an R squared value of about 0.86. And so basically saying that it was pretty consistent and accurate data. So this in turn showed that vibration data was in fact accurate and could be used in the future as a method of analyzing payment conditions. So the IRI and ZG data matched well, and this shows that GIS mapping and Excel data analysis in conjunction with the MATLAB syntax programming provides a systematic, fast, and accurate approach to retrieve data points among a huge amount of raw data. And this provides a more accurate and efficient method to do so. Thank you.